welcome to ESRIN. You'll have another welcome tomorrow because there's a separate session. We are very, very pleased to host you this year at the European Space Agency at its ESRIN establishment. The Salon de la Météo and ESA have over 20 years collaboration. I remember when we started this collaboration through our ex-director general, Jean-Jacques Dordain. We've been working together for years, so I'm very pleased that today you managed all to be at ESRIN. Thank you to Christian Varnier, to all the team of the Salon de la Météo, because as Eleni said, and she's really representing me there today because I can unfortunately not be in person with you, it's really a pleasure to have this connection with the Salon de la Météo, but especially with you. You're all very knowledgeable, I would say, spokespersons of what we do with our data, what you can contribute to the wider meteorological, climate, environmental domain with our data. Maybe if you allow me, I will take off my camera because I see my connection isn't stable, but you've seen me, I'm here, and I will continue the presentation. So let's start. I'm going to tell you a little bit about what ESA is, where you are today in ESRIN, and about Earth observation at ESA. And then you can have a question and answer session where Eleni will be there ready to respond to your questions. And if we go to the first slide, just to fit you in where you are today, you are at the European Space Agency. So first slide, that would be great if it comes up. ESA and the European Space Agency is an intergovernmental organization that has celebrated its 50th anniversary last year, so created in '75. Today we have 23 member states. They're European members, plus we have Canada, which is really a cooperating state, very active at the same level of full member of ESA. We don't have one-to-one the same members as the European Union because we have mostly countries who have space expertise. So we have in ESA Norway, the UK and Switzerland, who are not member of the European Union, but we work very closely with the European Union at European level and with other relevant organizations like EUMETSAT, of course, that you know very well, ECMWF, and all the actors at European level, which have a different variety of membership. We have today in ESA a workforce about 6,500 people. It's on various sites. You are in one of the ESA medium big size, ESRIN, which is also known as the Center of Reference for Earth Observation. We have delivered today overall in ESA a lot of satellites and missions, over 150 missions, from the space science to astronomy to telecommunication missions, of course, Earth observation meteorology missions, but we also have the contribution to the International Space Station, which is important, the astronaut work, and the technology preparation activities. And we have a yearly budget today of about €8, which we say is still not enough in space in Europe as an investment, as today, if you look at it's the investment which corresponds to about €15, a few coffees per year of European citizens. So compared to the US, for example, it's quite a low investment overall in space. If we go to the next slide, you see overall in the ESA budget, the relevance of Earth observation. In fact, you see here the annual budget for 2026. In that context, Earth observation as a domain accounts for about 30% of the overall budget, with 2.5 billion this year to be spent in industrial contracts on the projects that we have. And those activities are really, supported at the level of political level from member states. Of course, the climate crisis, but also the sustainability topics, the environmental topics, and today the security and resilience are very high on the agenda of our member states, and that's why the big share in that budget. If we go to the next slide, we see what we are doing here in the context of ESRIN. As I said, ESRIN is known as the Center of Reference Earth observation in ESA and in Europe. We work on many activities, but mostly on the acquisition, the data distribution, the demonstration of scientific and application activities of Earth observation data. We distribute those free and open to the users via web interface. So you have to register, but you can collect the data. And we also archive those data sets. Of course, we do this with quite a number of infrastructure associated to the work we do, like high-performance computing, which is a new facility that has been organized to process high volumes of data, integrating AI, high computing capabilities to the volume of data we have to accelerate the processing of the data sets and all what we need to do in terms of having digital twins of the Earth and also predictive model. We also have a science hub. We host scientists from all over Europe and the world. I know that today here in the Salon de la Météo, we have many representatives also from outside Europe. We have 43 nationalities in ESRIN because we also host a lot of trainees who work on projects of collaboration with Africa, for example, but also Latin America, Southeast Asia. And we have 45,000 visitors per year, people like you who come for dedicated workshops, industry, scientific conferences, decision makers, and also a lot of open days for scientists and students to get to know what we do. If we go to the next slide, we see a little bit more in depth the relation to our work. Is not only in ESRIN Earth observation related, but we also have a team working on a small European launcher that is called Vega C. It's a launcher that was launched the first time in 2012. It's today operational with Vega C, and we are developing the new evolution of this launcher called Vega E. 12 countries contribute to industry, and this is really very important in the context of being to have European strategic autonomy, be able to somehow launch we need to build, and this is part of the European launcher family together with the Ariane 6, and soon with many more small launchers available. If we go to the next slide, we see again some activities related to ESRIN. I said to you, we host a science hub. This is a center where academic people, research, university people come to work on dedicated topics. We have, for example, work done on the evolution of the Mediterranean region. Very important, I think, in the context of what you're discussing here for the next 2 days. But also we have a lot of work going on the evolution of the Arctic region, and a lot of science activities connected to new modeling, new technologies, new capabilities, and really a connection among the scientific excellence that we have in Europe with all the science expertise centers working on of environment and climate. If we go to the next slide, we still see something that you will learn more about between today and tomorrow, that we operate at ESRIN since over 25 years. We operate the International Charter of Space and Major Disaster. It means that 17 space agencies have put together their efforts since over 25 years to put data available whenever there is a disaster event in the world. This can be an eruption of a volcano, can be a flooding, can be earthquake or anything that's related to natural disaster. And in that case, ESA from ESRIN, from where you are, organizes in rotation one lead member. This agency, we have members, as you see, from Korea to China to Germany to Japan to CONAI from Argentina, the US, India. So we put together all the data sets available to support having in a few hours a map of the event. So if it's a flooding, to see if there is still a road access available, or if there is still a flooding, you can do the damage assessment with that and see how to actually also reimburse, but organize is on site. This is a very operational mechanism that we have, very useful to make clear to citizens, to people who are not specialists of space, the value of space really in supporting our data. Overall, we go to the next slide. Do you hear me? I think you should try to go to the next one.
Simonetta, sorry, we lose you sometimes. So yeah, but so far so good.
Okay. Okay, so we also have at ESRIN a Phi Lab, which is a laboratory to support new startups, new companies like in the Silicon Valley. They have good ideas. Sometimes they don't know how to enter the market, how to get access to venture capital, how to get the expertise. And this is what is done in ESRIN by my colleagues who are really organizing and supporting new good ideas in the market, both in the space segment, but also in the product and value-added sector. Like we had an insurance company coming and assessing the damage from the hail and how to use Earth observation data in that domain. If we go to the next slide, we see more about what we do in general on Earth observation. Directorate is located as a director in ESRIN, but it's a big directorate with people on 4 sites in the Netherlands, in these are established in the Netherlands, in the UK, in Italy, and in France. And today we have different streams of mission. Here we are in the Salon de la Météo, and we do build since the 70s the new innovative missions in the domain of meteorology, together with EUMETSAT, the European Operational Meteorological Agency. What ESA does, we fund and we develop with industry the new missions. We launch them, and then when they become operational, of course, the distribution of the data goes via EUMETSAT, and also the Sirius satellite, the one which are the recurrent model, are funded via EUMETSAT, but organized in industrial contracts via ESA. We have launched last year mission. We will launch 2 more this year. We also have Copernicus contact with the European Union. This is a very important operation. You will hear more in this data. It's a continuity of data to support the agriculture statistic domain, the air quality. We have measurements from Sentinels of the air quality every hour, the air that we breathe. We do have also measurements on ice thickness, ice melting, evolution of the sea level rise, and much more, with continuity of data. And then we have science missions, and those science missions are a little bit like the NASA science mission that we developed to support scientific objectives. Today we have 24 Earth observation missions in operation. We are launching 43 this year between national missions and European ones, and we have a preparation of over 40 for the next generation. So quite a big program, and I must say collectively Europe, not just ESA, has the biggest wealth today to support challenges like the one related to climate change and environment. We support all the environmental conventions, and I must say we are seen as reference model in Europe worldwide by the Indians, the US partners, the Japanese, for the wealth of the data we have, for the wealth of the mission, but also for the continuity of the measurements that we have. If we go to the next slide, we see some examples of those science missions I was just mentioning. One mission we launched last year, which is fantastic, is Biomass. It's a mission that has a P-band radar on board. It looks at the capacity of tropical forests to absorb CO2 in a way like a scan, like a 3D view of those tropical forests, very important in this context of working on climate change and evolution. And we have another mission that we launched 2 years ago. It's called Earth Care. And this mission looks at the role that the clouds play in basically shielding from the radiation of the radiation towards the Earth, and basically in a moment where we are living a high increase of temperatures, these type of missions are becoming essential for our daily lives. If we go to the next slide, we see more of what we do in Earth observation with Copernicus mission. I told you those missions provide 350 terabytes per day of data. So you understand the volume of data. We have about 700,000 registered users that really get those data sets. Of course, if you only get the data, you cannot do much about it if you don't know how to process it and use it. But you see here some example of the use of those data, which goes from air quality, atmospheric monitoring, methane leaks monitoring, polar monitoring, evolution of the ice sheets, ice trends, icebergs, also the sea level rise, but also measurements in the area of land monitoring to support the common agriculture policy of the European Commission for the statistics and the land use, and much more. You see here some examples of applications. If we go to the next slide, we see a few really relevant examples of those Copernicus applications. Radar on the Arctic and Antarctic. You see the ozone monitoring that is captured by those satellites. But you see that we can also monitor nitrogen dioxide. And this is what we did during COVID, when you probably remember it was all the media, the reduction of NO2 over the biggest cities in Europe, but in many places in the world was 50%, and then it went back to the previous levels of NO2 compared to pre-COVID after the crisis was ended. If we go to the next slide, we see again something related to Copernicus, because Copernicus is a program that is built not on a technology push, but really on a user pool. So we have dedicated missions which are built and conceived, and now they're currently developed with European industry to support policy needs. I make you an example. The Arctic policy of the European Union, approved in 2018, is supported by missions like we will launch, like Crystal, which will look at polar ice, snow, altimetry on board. And then we have the CO2 mission, which is really a mission with 3 satellites that is being built and will be launched to support the global stock take of the UNFCCC in the context of climate, and to support everything that was the needs for monitoring anthropogenic emissions of CO2 related to the implementation of the Paris Agreement. We do support implementation the relevant European Union policy using the data, providing the data in the domain of land use and in the domain of greenhouse gases. If we go to the next one. What we do in the domain of meteorology. Okay. The weather forecasting, so I was mentioning to you, and you are all weather experts, I understand, that we have missions like MTG with an imager on board. This it's helping us to look at how to forecast extreme weather events, how to forecast hurricane events, and it's been launched 2 years ago, and then last year we have launched a sounder mission. We will launch another one, MTG. It's geostationary mission this year. Those are fantastic missions which have improved greatly the nowcasting capabilities, so real immediate capabilities, and also predictive models in terms of having a good prediction of extreme weather events, which, as you know, it's part of the biggest impact on today's economy, as it's also reported by everything that is done at the World Economic Forum every year. Among the highest impactful events on the economy, of course, the extreme weather events are part of that. We will launch also the second satellite this year of METOP second generation, the B model, and this is a different mission. It's also worked with the EUMETSAT and provides really important information with also a sounder on, with also, sorry, a Sentinel-5 on board from Copernicus. And you see some examples of that game changer I was talking about with the nowcasting and the various constellations that we have on board and planned. And if we go to the next slide, it's quite slow. I hope you can hear me. Today, everything we do, and I think you have a very important role in passing this message here, it's not just about understanding how our Earth looks like today. Do we have less forest? Do we have less ice? Do we have sea level rise? But also how the Earth will look like in case there is an increase of a degree or 1 degree temperature, or in case there is an evolution which we can somehow integrate in using the data sets we have, and we associate that to what we call digital twin models of the Earth. So evolutionary models, predictive models of how the Earth will look like if there is, for example, this 1 degree increase of temperature. And this is really what we are working on. This is also organized and managed through ESRIN, so you will have the chance to see more and talk more about these activities of digital twins. And if we go to the next slide, I wanted to show you just some examples, because it's not just about satellites, it's mostly about what we do with the satellites data. And here we have, with this digital twin, an example of hydrology. We work on the evolution of the hydrology of the Po Valley in Italy, but we do the same, for example, in the African continent. It's very important to understand the what-if scenarios, for example, if there is a risk of flood or if there is a risk of drought, which can impact, of course, the agriculture production. As you know, the Po Valley in Italy is 40% of the agriculture production in Italy. So it's very important to have these high-resolution hydrological models developed to understand better the evolutionary aspects and also the what-if scenarios. And if we go to the
Simonetta, I'm not sure if you can hear us, but we no longer hear you. We're on the CCI slide. Are you still there? Okay, Houston has a problem. Here she is.
So if we go to the next slide, maybe I will close, Eleni, and pass to you. We see the climate variables and all what we do in the context of UNFCCC. ESA works on 27 of the climate variables, so indicators of information related to the state of the climate, and we work on those integrated in the science community and in the context of UNFCCC, and we are always observers at the COP meetings on climate. And if we see the next one, I think we have a good example of how EO data are entered into the annual report, which is an important report that is developed on the state of the climate. This is the 24th edition, but this is done every year. In fact, you see the 25th edition that was recently released, and we contribute our data sets to the work that is done in that context. And then I have a very last slide, I think, before we conclude. And if we go to the next one, you see the example of forest degradation. You see an evolution of that from the 80s until 2025, and really what you can observe monitoring what is happening in the deforestation domain, but also in the reforestation domain, because Brazil was very good and actually has also reforested and not just deforestation happened there. I will comment on that. Yes, there is the one related to the Arctic, of course. Here you see the average annual ice in the Arctic. This is very important, not just for the scientists, it has also a very strong geopolitical dimension with rare minerals located now with the ship routing impact. So this is something we work using everything on satellites, the altimetry instrument that tell us about the thickness of the ice, the radar instrument that give us the view night and day of the Arctic region, but also the capability to look at really the extension of the ice, but the velocity of the ice. So all these parameters which are coming from different satellites are integrated into a full view of the Arctic evolution. Next one. The next one is an example related to sea level rise. As you know, we have been working, integrating data from US missions, French mission, European mission. We have now the most powerful satellite flying with an altimetry on board is Sentinel-6. It's operation, has two satellites flying. It tells us the trend on sea level rise. And the trend on sea level rise, as you probably know, because it has a lot of impact on small is an average trend increase from 3.5 millimeter per year to 4.8 millimeter per year. This is a stabilized trend in terms of increasing trend. And we look and we have to monitor this for long period of time with consistent data sets. And that's what we do with satellites in terms of another area where we really work with the scientists, with the environmental, with the institutions to give and provide information and objective data sets on this parameter of sea level rise. And if we go to the next slide, I think this is my last one, but I want to show you this one. It's the increase of temperature. You will talk a lot about this, I think, today and tomorrow. It shows you, it speaks alone, an image from Sentinel-3, so another Copernicus satellite that tells us about the land temperature. You see how the surface temperature in Europe on the 26th of May was really, really extremely hot with some almost 50 degrees temperature in some areas. I mean, look at Spain or look at some areas, including Madrid and London, really where Paris reaching extreme temperatures. This is not to see what happened that day, but to foresee the risk of. So we use this measurement more and more to do. But we also look at these, of course, to have an overview of the general evolution of climate and the environment in Europe. And with this, I'm very apologizing. I think the connection was not very stable, but I hope you managed to get what I told you. Otherwise, you're there in ESRIN with all the best experts, all my colleagues, and I'm sure they will follow up in detail on my presentation. They will be able with you today and tomorrow to discuss all the items, and Eleni can also follow up with the question and answer session. So good luck for today and tomorrow. Really happy again to host the Salon de la Météo because it's a super important vehicle to also make people aware of what is done and what is done with space for the citizens. So thanks a lot.